Yeah, yeah, yeah.
Okay, good. Okay, so today is a tutorial session, but I will still continue with the lecture because I want to finish the chapter 1 as soon as possible, okay? All right, so let's continue the second part of the lecture 2. That is the classification of signal. So a signal can be classified into several cases. The first one is a continuous time and discrete time. So continuous time and discrete time, for this one, we will study in the signal and system continuous time and discrete time. Mostly we use it in the digital signal processing, but I will still introduce to you what is continuous and discrete. Okay. Okay, either in the time axis and y-axis. So time axis is referred to the x-axis and y-axis is referred to the value. What is the value? Okay. And then after that, the second part of the classification of signal is a symmetric, and then you have the periodicity and the energy and power signal. So for today I will cover these two first, continuous time and the symmetric. So first of all, let's look at what is continuous and discrete signal. Here we have four classes. Okay, continuous time and continuous value. Okay, let's look at this figure. Continuous time and continuous value. Continuous time, this means that for the t-axis or for the x-axis, the time is continuous, it's non-stop. Okay, you can see the wave is non-stop. That is continuous time. Continuous value means that every at y-axis, every single y you have the value, so it's a continuous value. Then second one is the discrete time continuous value. If you look at this one, this is discrete time. Discrete time means that um, the time is not continuous. Okay, example at a certain time. For example, this one, if you look at the first one, continuous time and continuous value, this one is say that, okay, if you look at here, 0, 0.1, 0.2, 0.3, up to 1, 1.1, 1.2, up to 1, 1.9, then 2. Every single uh, y, every single t, you have the value. Okay, then for the discrete time, it only sample at 0, 1, 2, 3, 4, 5, like this. Okay, so you can see it's a discrete. And if you notice that is the discrete time is we use the n instead of use the t. We use the n, okay? And the continuous value for the y-axis is each one we still have the value. Okay, different value. So it's a continuous value signal. And the third one is the continuous time discrete value. Continuous time, this means that t is a continuous. Okay, each t you have the continuous time. And then for the y-axis, the value is it stop a while. For example, this is 1, 2, 3. Okay, 3, 3, 3, 3. Then you have the 2, 2, 2, 2. Then 1, 1, 1, 1. Then 0, 0, 0, like this. So the value is it's not different. It's not every single time you have the different. But it's stop uh for a while. Okay. And then for the continuous time and discrete value, okay, the time is continuous. You can see that the graph is continuous, but the discrete value is stopped like this one, maybe 0 and 1. Okay, 0, 1, 0, 1, 0, 0, 1, 0, 0, 0, then 1. Okay, so this is considered also the digital signal as well. So these are four type of the or four classes of the continuous and discrete signals. And this one is referred to the continuous time and continuous value. You can see that there is a continuous time. Also, the value is continuous, but you cannot identify what type of signal it is. Okay, so we may consider this is the noise. If we do not know what is the signal is, so we consider a noise. And the last one, it is the digital signal. Negative 1, 1, negative 1, 1, 1, negative 1, 1, 1, negative 1. But the signal is not sharp. Okay, there's a noise. at the top or at the bottom. So we say that it's a noisy digital signal. Okay, next is the continuous time signal. Okay, continuous time signal means that the amplitude vary continuously with time. Okay, you need to know that continuous time is amplitude vary continuous. Okay, amplitude vary continuous with time. Okay, for example, it's a voltage and velocity and denoted by the xt. Okay, continuous time is xt. Short form is ct, and normally we use the as a xt. Time interval may be bounded. Okay, bounded means there is a finite, or unbounded is infinite. For example, amplitude value present at all time during the intervals. Here is the typical example of the continuous time signal. For example, this one is periodically, this is the same, it repeat again. So this is amplitude modulated carry in the communication system. Okay, or this one also continuous. Okay, this is the step response of the resistor and capacitor low pass filter. So the step response also continuous. This one is like I think most of you, if you drive a car, you will experience this. Let's say you pass through your car pass through a bumper, but this bumper is newly made, which is don't have the yellow line, yellow strip line, so you don't know that is the bumper there. So you just drive quite fast and you pass through the bumper. So you will have this kind of signal. Okay, this kind of signal, which is this is could be from the front tire, and this is from the back tire. So if you can hard to imagine. So if you drive a car, you try to pass through the bumper without press the brake, so you will have boom boom like this. So this is the signal. And then light intensity from a Q switch laser. This is the light intensity. Another example, I would say the lighthouse. Okay, if you just stand at the one location and you see the lighthouse, and periodically the light, okay, uh, you will see the intensity of light lah. If you look at the direction of the light. Okay, this is the light intensity. And this one is the frequency shifting. It's a high frequency, low frequency. So you have high frequency, low frequency, high frequency, low frequency. So frequency FSK, okay, FSK. And this one is the baseband binary bit stream, okay, 0, 1 and -1. Okay, it's a binary code. And then this one is the equation for the continuous time signal, sinusoidal signal. GT is the A cos 2 pi t over t naught plus theta. Okay, this A is referred to the amplitude, and then 2 pi t over t naught. T naught is referred to period. Okay, the fundamental period plus with the phase shift. Okay, phase shift. This one actually you learned it before, but different sign. That one is the phi. That one is a phi. This one is a phase shift, but it's still the phase shift. Okay, equal to the second equation. Actually, this F naught actually is equal to 1 over T naught actually is equal to 1 over F naught. So this one actually is equal to this one. Okay, T naught is equal to 1 over F naught. So but this is in frequency, but this one is in time. Also, you can represent the equation into a radian per second, which is omega naught t. Okay, omega naught is referred to 2 pi f naught. Okay, this omega naught is referred to 2 pi f naught or equal to 2 pi over t naught. It's the same things. Okay. Any question before I move to discrete time signal? Any question, class? If no question, then I shall move to discrete time signal. So discrete time signal, we normally name it as xn. Okay, n is referred to discrete if t is continuous. Okay, xn which has the amplitude of the signal vary at every discrete value. Okay, amplitude of the signal vary at every discrete value. Okay, we are talking about the discrete. Just now is talking about the continuous. Okay, which is generally uniformly spaced. Okay, uniformly spaced means that each space is the same size. Okay, uniformly spaced is each space is uniform. Common example include the pixel, daily stock price, or anything that computer process. So also denoted by the xn, which n is an integer value that vary discretely. So this is the difference between discrete time and continuous time is this one xn, another one is xt, and this one it should be the n, another one is t. Okay, then let's look at this one. A discrete time signal can have a continuous value or can only have assumed a predetermined set of value. Okay, if you look at this one, a continuous time signal going through a sampling process will produce a discrete time value signal. Quantization of this discrete time signal will be produced discrete time discrete value of signal. Okay, this one is a discrete time and discrete value. Okay, do you know how to maybe in this topic you won't in signal and system you won't in detail how to get the sampling and quantization, but normally the process is from the analog signal you pass through from analog signal, how to get from analog signal to a digital signal, you must pass through the sampling process. Okay, you pass through a sampling process, after that you pass through a quantization process, then you pass through the encoder process, then you will get the um, binary digital signal. Later I have the figure for you, but this is just a introduction. The further detail you will study in the digital signal processing. Okay, because this one is about digital, but we are now talking about the continuous time, but just give you a briefing only. Okay, this is the comparison between the xt and xn. So xt is a continuous in time. Xn is also continuous value, but it's a discrete time. You see that discrete time 0, 1, 2, 3, 4, 5. Okay, but the amplitude is remain the same. We didn't change the amplitude, we just changed the time. The time is changed to discrete. Okay, this is the one that I told you just now for analog to digital, so-called analog to digital converter. Okay, first of all, you have the analog signal xt, where this analog signal is a continuous value and continuous time. Then you need to pass through a sampling. Sampling is you take a sample. You want to sample at which period. For example, I take the sample at every 1 second. So 0, 1, 2, 3. Every increment is 1. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or I want to take every 2 sample. So 0, 2, 4, 6, 8, 10 like this. So I will take the value of that sample only. For example, I take 0, 2, 4, 6, right? So I take the y value at 0, at 2, at 4, at 6, and at 10. Like this is a sampling. Okay, quantization is so for the sampling is a continuous time, discrete, continuous value, discrete time. For quantization is we sample at the we quantize as the y-axis. This means that each one we have the a continuous value, but now we want to make it discrete value. So how to make it discrete value? So we will have we draw each line. That's why you see the line here. It depends on how many bits. For example, I want 4 bits, so 2 times 2 is equal to 4 bits, right? So I will have the code is 0 0 0 1 1 0 and 1 1, so it's 4. So I have a 4 level, so I'll put 4. This one could be more than 4 lah, or maybe 2 times 3, 2 power of 3 is 8, so you have 8 lines. But 8 lines, so you have 2 types of quantization method. Okay, either is a near a quantized value, so you use the quantized method to get the quantized value. So this quantized value is so called the discrete value. And lastly, just now I told you you have the encoding. Encoding is each one you already have the quantized value, and then you change to code. Code is a 00, 01, 10, or 11. This is a 4-bit. If you have 8-bit, you have a 000 up to 111. If you have 16-bit, you have 0000 up to 1111. Okay, 16. So this one from here, after encoding, you will get a digital signal, which is only 0 and 1. Okay? Anything you want to ask for this slide? Anything you want to ask, class? If not, I shall continue again. And then I will let you know what is the analog and digital, what's the difference between analog and digital. So for this analog, if you look at this figure, so this is analog signal. And then we want to change it to digital signal with only 0 and 1. Okay, there's a difference. And then, so we finish the continuous time and continuous time and discrete time. So before I go to second part of the symmetric, so if you have not understand about this one, you can ask me. Okay, any question? If no question, I shall continue. Okay, so second part is the symmetric, even symmetric. Okay, for symmetry, you have three types: even symmetry, odd symmetry, and asymmetric. Okay, for symmetry, if you look at this one, a continuous time signal xt is said to be even symmetric if it satisfies the condition xt equal to x minus t for all t. This means that st is equal to x minus t. What is this? And an even signal are symmetric about a vertical axis. Okay, this refer to the symmetric at y-axis. Vertical axis means refer to the y-axis. So even symmetry, this means that there is you put a mirror at the y-axis, then you will get the another half signal. Okay, you get what I mean here? Okay, this is the cos signal. Okay, this is the cosine signal is here. Okay, if you put a mirror here in the at the y-axis, you will get the negative part of signal. So therefore, I would say if xt is this refer to this cos signal, then is equal to x negative. So this is the negative side, okay, of the signal xt. So if even signal, this means that is the mirror image. Okay. Mirror image at y-axis. Alright, and then okay, if you want to is another type of signal is a rectangular signal. Okay, if mirror image at the y-axis, you get another half. Okay, so it's the same equation like this. For the odd signal, okay, odd signal must fulfill xt equal to negative x in the bracket negative t. Okay. Okay, this is the sine wave. Okay, sine wave. Okay, the sine wave looks like this. Okay, for odd symmetric, you must two time of symmetric. First of all, you put a mirror here, so mirror image at the y-axis. Then you will get, okay, I draw here. Okay, first of all, you mirror. This is the original signal. Okay, first of all, you have the uh, mirror image at the y-axis. You obtain like this. Am I right, class? Am I right?
Yes. Yes, doctor.
Okay, and then after that, you mirror image at the x-axis. Okay, you mirror image. This means that you put a mirror here. You will this one you will get here, and this one you already cancel out. I don't want already. And this the bottom part it will change to the positive part. Okay, so I will get the signal exactly like this one. So this means that it's the 2 times of mirror image. Okay, first of all is then y-axis, then followed by x-axis. Okay, can you understand, class?
Yes.
What about others?
Yes, doctor.
Okay, all right, good. So the third type is the asymmetric signal. Asymmetric signal means that the signal uh, neither even nor odd can be expressed as sum of the even and odd signal. This means that asymmetric, for example, I have the signal like this, and then like this. If the signal like this is neither even nor odd because this side is not the even. If even, it should be like this. If odd, then should be. If odd, then you have to calculate lah. But this one definitely odd should be in this way. But this one, the curve here is not fulfilled. The odd symmetric. So it's neither even nor odd. Okay, and then the three equation here you must remember is quite important. Xt equal to x even plus x odd, and then x even equal to xt minus x minus t, xt plus x minus t, and then divide by 2. And then else x even and x odd is xt minus x minus t divided by 2. So these three equations you must remember because in the exam there is quite a famous question to ask. Okay, find or draw the even and odd part of the signal. Okay, so you must use the formula to get it. Okay, you must use the formula to do it. You cannot just draw only. It's draw, then I don't think you get the answer. For the characteristic, you can uh, use for check the answer. But to find the even and odd, you must use this formula. Okay, so these three formula is important. Okay, I give you this one is a exercise. You can try also. This one also exercise. So I give you the example. I show the exercise, the answer for the B. Okay. Okay, let's do this B. Find the even and odd parts component of the signal below. Okay, if give this kind of signal, so you must use the formula. Okay, this is in order to solve this question, you can transform it into a table form. Means it's easy for you to see. Okay, I would recommend you to use the table form. Okay, this is a figure of xt. Okay, first of all, you need to know, you need to transform this figure into the table form for the xt. Okay, for the xt, if I want to write the value from -2 to 0, okay, how to transform it into a table form? So first of all is when t equal to -2, okay, I have the value of what? Can you tell me?
-2.
-2. And when t equal to 0, I have the value of
-2 also.
-2 also. Okay, that's why you have -2 and -2. And then for 0 to 2, this part, I have a different value. So when t equal to 0, what is the value? Here,
0.
0.
0,
And when t equal to 2, what is the value?
2.
2. Okay, so you have 0 and 2. This one, understand? Okay, then we proceed to x negative t. X negative t means that you need to put a mirror at the y-axis and you get the x negative t. Okay, I want to put a mirror here. So initially the signal is like this, right? So if I put a mirror at the y-axis, of course this part will move to this part and this part will move to this part. So at the end, I only have this signal left with this is negative 2, this is 2. The positive 2 will change to negative 2, negative 2 will change to positive 2. This one okay? Amplitude still remain the same. Okay, the mirror is just a normal mirror. There's no zoom in or zoom out mirror. Okay, class? And then from here, this is x negative t. Okay, from here, you can transform this figure into a table. From negative 2 to 0, this one, negative 2, you have the value of what? What's this value? This is 2 lah, because it's referred to the same value, 2. And then when t equals 0, you have the value of 0. And just now is 2, now you have 0. And then at from 0 to 2, okay, at t equals 0, you have the value of negative 1. Sorry, negative 2. You have negative 2. And for t equal to 2, you have the value of negative 2 also. Is it okay, class?
Okay, doctor.
Okay, right. So now you need to perform. This is referred to x even. This is referred to x odd. Okay, this is the formula. You still remember just now I show you x even and x odd. This is the formula. Then we use it here. For x even, okay, xt plus x minus t divided by 0.5, divided by 2 lah. So this means that negative 2 plus 2, okay, you will get 0. 0 divided by 2, you get 0 also. Negative 2 plus 0, you get negative 2. Divide by 2, you get negative 1. And then 0 minus 2, 0 plus minus 2, you get minus 2. Divide by 2, you get minus 1. And then 2 plus minus 2, you get 0. 0 divided by 0, 0 divided by 2, you get 0. So this is how you get this x even. So once you get the x even, you can plot it. Okay? Okay, you plot when t equal to negative 2, you have the value of 0. When t equal to 0, you have the value of negative 1. And then when t equal to, for the 0 to 2, for t equal to 0, you have the value of negative 1. And from t equal to 2, you have the value of 0. So you just draw the line. Okay, then after you get a signal, okay, this is a signal, so-called x even, and then you check. Okay, just now I told you you must know the characteristic of the even and odd, right? Okay, for even signal, this is the characteristic. Okay, mirror image at the um, y-axis, and then for odd signal, okay, we talk about even signal first. Okay, mirror image at the y-axis. Okay, then we go back to your question. Is it mirror image at the y-axis? Is it mirror image at the y-axis?
Yes, doctor.
Yes, if it is a mirror image, this means that the answer is correct lah. So you can actually, if you know the characteristic of the mirror image, you actually can confirm that the answer you calculate using the x even formula is correct. Okay, so the characteristic actually is to double confirm the answer you find it from here is correct, because this picture show that this is the characteristic of x even. Let's say if you plot the graph is like this, if you plot the graph is like this, and then you get like this, then is something wrong, because this graph is not even. Okay, actually, so you get what I mean here, class? Oh, class.
Yes, doctor.
Okay, please, class. Since this is online, I don't know whether you understand or not. So please respond to my question so that I know that you are with me. Otherwise, I don't know you are with me or not. Okay. Okay. Next, we go to the x odd. X odd is xt minus x minus t, and then divide by 2. Okay. So similarly, you have minus 2 minus 2. So it's a minus 4. Minus 4 divided by 2 is minus 2 lah. Then minus 2 minus 0, you get minus 2 divided by 2, you get minus 1. And then this one, 0 minus minus, so you get positive 2 divided by 2, you get 1. 2 minus minus 2, so you get 4 divided by 2, you get 2 also. Then you plot this graph. Okay, you plot this graph. Negative 2, when t is negative 2, you get negative 2. When t equal to 0, you get negative 1. And when t equal to 0, you get positive 1. And when t equal to 2, you get 2. So you draw the line like this. Okay. So you check again if this figure is odd characteristic. Okay, you can double check. Okay, first of all, uh, you see this figure is, first of all, is a mirror image of the y-axis or not? Okay, and then mirror image at the x-axis or not? If yes, then that would be the odd signal. Then your answer, you know that your answer is correct. So any question to ask? That is about the even and odd signal in which you need to use the formula to solve the question. Any question to ask us?
No, doctor.
Huh?
No, doctor.
Okay. Then we go to the module. Okay, from the module, you also can see that this is the even and odd. Okay, even is look like this. Okay, this is even also. Okay. Okay, here mentioned that even exponent does not always make an even function. For example, t plus 2 t plus 1 square is not an even function. That is referred to this graph lah. And for the odd symmetry is this one. Okay, you know that this is the odd characteristic. Okay, sinusoidal wave is the odd symmetric. Okay, and this one is odd also. And then I show you this one is neither odd nor even, so we so-called asymmetric signal. This one is asymmetric, because if you want to get the it unable to mirror image at the y-axis. Let's say you want to mirror image at the y-axis, it should get like this, something like this. Hey, how I cannot draw already? Why I cannot draw? Something problem with my pen. Okay. Okay, my drawing is not too good, but it's something like this. If you draw for the right hand mirror image at the left hand side, it's like this, and then your mirror image is like this. Supposedly, for the graph of the odd, it should be one is here, another one is here. But this graph, the graph is here, so it's not neither even nor odd. You get what I mean here, class?
Yes, doctor.
Yes, doctor.
Okay, thank you. Alright, so this is the three equation that I told you is important because most of the exam you will need to use these three, this at least these two. These two is very important because you have to remember the difference between x even and x odd, just a plus minus. Okay, so the method to calculate is you can show it in the table form. You transform in the table form, which is much easier. And then this proof actually is to show the how to get this equation of x even and x odd. You can read on your own. The step is here. I think this one is not equation 1.31. This one should be 1.29. Okay. Okay, and this one is talk about the even and odd part also. Okay, for the even, this is the even character. For this signal st, this is the even characteristic. For odd, this is the odd characteristic. This one is just to show you, okay? But definitely, if you want to get the proper way, you transform it into the table form, which is easy for calculation, especially the graph. For example, this graph is considered easy, but those graph is considered complicated. You must use the table form, which can ease your life. Okay. Okay. For example, this one is just in term of the table. I didn't this in this module didn't put the table form. So it's still using the odd signal, okay, but it just show the answer. You can try using a table form. Okay, check whether you got the answer, correct answer or not. Okay, you use a table form, you check the correct answer or not because for this part, you have the gradient, you minus with something this one, so you get this part, uh, like this. So you can transform into a table form. But if you don't want to transfer the table form, also can. But you need to totally can imagine. If you're unable to imagine, then transform it into a table form is a safer way. Okay, it's a safer way. Okay, next is the special property of the symmetric. You have the adding or multiplying. Adding is a sum. Okay, multiplying is a product. Okay, so the sum of the two function. This means that even function plus with the even function, you got even function. Okay, sum of the two odd function, so odd plus odd, you get odd. And then even plus odd, you get neither even nor odd. For the product, okay, even multiply with even, you get even. Odd multiply with odd, you get even function. Okay, remember? Odd multiply with the odd, you got odd function. Sorry, you got even function. And then even multiply with odd, you get odd function. Okay. I think this one I can show you in this. Okay, this is an example. Okay, this one is even. Okay, even function multiply with even function, then you got this graph. So this graph is a even function. So even multiply with even, you get even, which is this one. Even multiply with even, you get even. Okay, odd and odd. So this is odd. Multiply with odd. So odd and odd, you get even. Okay, which is refer to this one. Odd and odd, you get even. And then product of even and odd function. This one is the even, and this is odd. So even and odd, you get what? Even and odd, you get odd. So this is refer to this one. Even and odd, you get odd. Okay. So then we go back. Is there any question, class?
No, doctor.
Okay, we can refer to this example 1.18. Which one of the following function is even? Okay, for the first one, x power of 4 plus x power of 3. X power of 4 plus x power of 3, what do you get? Okay, the answer is sum of the even and odd function is neither even nor odd. You get what I mean here? This is even, this is even, and then this is odd. So sum of the even and odd is neither even nor odd, which fulfill this one. Sum of the even and odd is neither even nor odd. Then this one, even and even. Okay, 4 and 2 is even and even. So B is sum of the two even functions, so it's even. C, x power of 5 and x power of 3, both are even, are odd. Okay, so sum of the two odd function, so are odd function. And this one, x power of 3 and x power 1, so this is also odd. So sum of the odd function are the odd function. Okay, then what about this one? Given a function f, g, and h, which of the following product is odd function? Okay, f and g, this is x squared plus 1, and then x power of 3 minus 3x. So f and g is the product of even, okay, even and odd function, so it's odd. So this is refer to the properties. Product of even and odd, you got odd. Okay, next is g and h. G is even and odd and odd. Okay, so g and h is a odd, and another one also odd, so it's even. And then f square is a product of even. F square is this one, is a even. Okay, product of even and even function, so it's even. And lastly, f, g, and h. So f is even, odd, odd. f, g, h is the product of f, g, and x and h. So it's a product of odd and odd function. Odd and odd function, so it's a even function. So okay, is there any question? Class? Is there any question?
No, doctor.
Okay, if no, we take a rest and come back again. We do exercise. Okay, we take a 10-minute break until uh 11:58. Okay, 12 o'clock. Then we come back here. Okay, see you again.
Okay, doctor.
Doctor, did I miss the attendance? Doctor? Doctor? Hello, doctor? Doctor?
Okay, class, welcome back. Then those who already come back, then you must try to do the exercise 1.6 at the page 37. Okay, try to do question 1 and question 2. Okay, we do the question 1 first. I give you 10 minutes. You do question 1. Okay, page 37. Question 1. What is the event signal in example 1.18? Okay, 1.18, example 1.18 only show the odd part. So the question requests you to find the even part. Okay, you can. I give you 10 minutes to do this question. Okay, let me share with you how it's going to work for this question. Okay, Louis Down said he don't know how to do. Okay, if you look at the question here, this one, what is the even signal in example 1.18? Okay, so now this is the signal. Okay, this is the signal. We want to do this signal. Okay, we want to solve this signal. Okay, maybe I copy this figure first. Okay, then I want to draw a table. Okay, so first of all, I want to draw the range. Okay, draw the range. The range is from -2 because this one xt, you know that this is from -1 until 2, but x negative t is the mirror image of xt, so there is a graph from -2 to +1. So I write it properly. I write it first from t up to -1 to -2 to -1. Okay, can you see my writing? Okay, and then this one is t equal to from -2 to -1. So this is t equal to -2, and then another one is t equal to -1. Okay, and another one. So you just fill up the range first. So this one should be -1. Okay, and then to 0. And then this one is 0 to 1. And then this one will be 1 to 2. Okay, so this one for t equal to -1, and then t equal to 0. Yeah, it auto correct, or t equal to 0, and then t equal to 0 also. Then this one is t equal to 1. Then t equal to 1. Then t equal to 2. Okay, now this one I want to fill up for the value of xt. Can you tell me, class, can you tell me on your mind? I want Jackie, Haika, Muhammad Haika, and Muhammad Nazwan. Can you tell me what is the value for range -2 to -1? What is the value for t equal to -2? Just on your mind and tell me.
Zero.
0, okay. What about others?
One.
1? No. Okay. And then I said from range -2 to -1. Actually, -2 is here. This is -2. -2
Kita
to
angkat ni.
-1. So what is the value when t equal to -2 is 0, and when t equal to -1 also 0. Okay, I want Nick Muhammad. Can you on your mind what is the value when t equal to -1?
Zero.
0. Okay. And then for range -1 to 0, which is this one. Okay, what is the value for t equal to -1? Dahwin Nae. Darwin, please on your mic and tell me what is the value. The value here. The value that you can see. Here. 0 lah. Okay. And t equal to 0, you take this value. So your value is 1.
1.
Okay, from 0 to 1. Okay, from 0 to 1. When t equal to 0, you have the value of 0. 0 to 1. Yeah, sorry, you have the value of 1, not 0. And then for t equal to 1, you have the value of 1 also. When t equal to, for the range 1 to 2, for t equal to 1, you have the value of 2. And t equal to 2, you have the value of 2 also. Okay, and then I want to get x negative t. This means that I need to draw another one and the mirror image at the y-axis. So I told you, right, this one should be from 2 you change to -2, from 1 you change to -1, from +1 from -1 you change to +1. So you will have the graph like this. Okay. Okay, for x -0, for x negative t, for t equal to -2, okay, you have the value of 2, and when t equal to -1, you have the value of 2 also.
1.
Okay, and then for range -1 to 0, when t equal to -1, you have the value of 1, and when t equal to 0, you have the value of 1 also.
1.
Okay, so when for the range 0 to 1, when t equal to 0, you have the value of
1.
and then when t equal to 1, you have the value of 0.
0.
And then for the range 1 to 2, you have the value of 0 and 0. Okay, now I want to have the x even. X even t. X even t is xt plus x minus t divided by 2. Okay, 0 plus 2, you got 2. 2 divided by 2, you get 1. Okay, this one also the same. 0 plus 1, you get 1 divided by 2, you get 0 0.5. 1 plus 1, you get 2. 2 divided by 2, you get 1. This one also 1. This one is 1 plus 0 divided by 2, so it's a 0 0.5. This one is 1. This one also 1. For x odd, is xt minus with x minus t divided by 2. Okay, 0 plus 0 minus 2, you get minus 2. Minus 2 divided by 2, you get minus 1. This one
Negative
also
1.
minus 1. Okay, and then 0 minus 1, you get minus 1. Divided by 2, you get negative
0.5.
0 0.5. So 1 minus 1, you get 0. 1 minus 1, you get 0. 1 minus 0, you get 1. Divided by 2, you get positive 0 0.5. And then 2 minus 0, you get 2. Divided by 2, you get 1. This also get 1. Okay, so you can plot the graph now. Okay, so now let's prove that. What do you get from the answer in the how to get the answer for page 39, how to get the x odd. Okay, for x odd, okay, we draw the x odd first. You have a negative 2, negative 1, positive 1, positive 2. You have 1, 2. Okay, so negative 1, negative 1, negative 1, negative 1, and then negative 0 0.5, and then 0. Okay, so you draw like this. After that, you have 0 and positive 0 0.5. You have 1 and 1. So you draw like this. Okay, is it same as the answer in page 35? Same or not?
Same.
Same. Okay, so this is x odd. For the x even, okay, for the x even, okay, we look at this one. Okay, so you have 1, 1, 1, 0 0.5, 1, and then 1, also same 1, negative positive 0 0.5, and then you have 1 and 1. This means that you follow the sequence. Okay, maybe the scale here is not the standard scale. Okay, let me draw again. This is 1, this is 2. Okay, for the range 0 to 1, you have 1 and 0. 1 and 0 0.5. So like this. Okay, so this is x even. Then at the end, you check your answer whether this one fulfill the even characteristic, okay, which is mirror image at the y-axis, and x odd is a mirror image at the y-axis first, then followed by x-axis. So this is how you get the answer for the Q1. Okay, class clear? Eugene
Okay,
is hard
doctor. Doctor.
hard but this is a
Doctor,
common
for
question.
the question, he asked what is the even signal. So can I just draw the XE only?
You draw the even signal.
Ah,
Even signal
means
of the xt.
I don't have to draw the X odd, right?
Yeah, yeah. If the question asks you to draw the x even, you just draw the x even lah. But the way to the draw part is this one. The draw part is this one, but the process to get is this. You calculate
Yeah,
xt, x minus t. Just
even if I'm using the table form, I just have to do until the X even only, right?
yeah, 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 correct. But this one
Okay,
I
I
want to
understand.
X out is want to show you because just now I said that example 1.18 don't have the table form. Since it's the same question, I show you how to get the answer of the example 1.18 lah, because it's the same question. One is odd and the exercise is even. Mm,
Okay, doctor, I
yeah.
understood already.
So
Thank you.
if you that's why I said you put it in a table form. It seldom will make mistake lah. Okay, you follow the format like this. You follow this table form. You transform the diagram, the value in the diagram to a table form, which is easy for you. If you want to illustrate in your mind and then you do the plus and minus, perhaps it's hard lah. That's why I said you transform to a table form, then you do plus and minus, which is easy. I'm not sure which type are you, but somehow people like to imagine, huh? Imagine. But when you imagine, once the answer is wrong, all gone lah, because there's a marks for the step, right? So you don't have the marks for the step, so I didn't consider you also you correct lah. Or even you write the correct answer, you draw the correct graph, but without a table, okay, or show the step to me how to get it, you will get the mark for the diagram. Okay, this how we marks lah. Okay. All right. Any question? I know this hard, but this is common question, so you have to study. You have no choice. All right. Okay. Any question? If no question, you got to do the remaining question. Question two, also the same. Uh, you have to do question A, B, C. Okay. The answer is in the okay in it show in below the question exercise, and I need you to submit. I need you to submit question two, ABC, in the auto platform under individual activity. Under individual activity, the deadline is 1 week. Okay, 1 week before the coming class, coming tutorial. Okay, I want you to practice. Okay, since this is hard
Doctor,
for
the
you.
exercise you gave us yesterday,
Huh? What? Which one?
the exercise you mentioned just now.
The mention this now is exercise 1.6. Exercise 1.6, do question 2A, 2B, 2C. Yesterday one is different. Yesterday one is the tutorial 1.2, if not mistaken. 1.1 or 1.2. Tutorial 1.1. Yesterday is the tutorial 1.1. That is the yesterday. Today one is the exercise 1.6. Okay?
Okay,
Uh,
doctor.
so since you already do the
Uh,
question one, so I won't ask you to submit the question one lah, but you still need to do it, but you don't need to submit. Yes,
Doctor, which question, Doctor? Question two?
to ABC.
Oh, okay.
Uh, okay. If there's nothing else, I will take the attendance, and that's all for today's class. And see you again on next week. So you get ready with your QR scanner. I know that for the first time it's not easy for you, but that is how you need to study lah.